Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just attempt to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So the problem that I'm going to be attempting today is number 3000, maximum area of longest diagonal rectangle. So I'm just going to read out the spec here. It says you're given a 2D zero-indexed integer array dimensions. For all the indices from 0 to the dimension's length, each index and dimensions, if you go into each index and go to index 0, it'll be the length, and then at index 1 it's going to be the width. Return the area of the rectangle having the longest diagonal. If there are multiple rectangles with the longest diagonal, return the area of the rectangle having the maximum area. Okay, so first thing we need to do is figure out how to get the longest diagonal. And here it looks like they're basically just doing Pythagoras theorem. They're just doing a squared plus b squared, a squared plus b squared is equal to c squared. Yeah, so they square root all of this to get the length. So what we're going to do is go over to our notes and write down any ideas. So idea is iterate through dimensions, calculate the diagonals and add to array, find the max out of the diagonals. If there's two, select the, if there's two, select the uh, calculate the diagonals in a array. If there's two, what we're going to do, we're going to select the one with the biggest area. Let's attempt this. So we're going to do for dimension and dimensions. Diagonals dot append um, um, diagonals dot append. We're going to do dimension at index 0 times dimension at index 1. Now is there a square root in Python? Math.sqrt. Oh. And then let's just print diagonals. It's this, in fact no, it's this times this plus this times this. Oh, I've not defined this up here. So we get 9.4 and 10, which matches up with this. We also need to keep track of the, what you call it? We need to keep a track of the area. So we need to just do results dot append, and we'll do this will be at index 0, and then we can put at index 1 we can do dimension 0 times dimension 1. Let's try that. Let's call this results. There we go. 48, so that's the highest. I'm actually going to have a look at the hint and see if there's anything that we can use here. Oh, we got that. The diagonal of a rectangle is the length squared times the width plus the width squared, all square rooted. It's not very useful. Okay, so we need to find the longest diagonal. So we're gonna do for result and results if result is greater than max diagonal is that his word? Yeah. Then this is going to be equal to the result. We're also going to check if no, we can do this at the end. Else, or no, we don't even need to add anything else. We do if result is greater than max diagonal is equal to result. Cool. So we should go to just print max underscore diagonal. I will just set it to 0 to begin with. Oh yeah, result 0. Hmm. It's a bit weird why that's not working. Let's just print result. Okay, so we get this is not supported between float and list. It's a bit strange. Max diagonal is definitely... Oh, here is the problem. Still doesn't work. Result 0 is greater than max diagonal. Max diagonal is equal to result 0. Print max diagonal. Strange. Okay, it's a bit weird. Both times 9 is bigger than 9, and then 9 is bigger, or 10 is bigger than 9, so it prints it twice. But it seems to reset. Let's see if I print max diagonal here. It's 0 every time. I'm just gonna have it return a random number so I don't get this runtime error. Okay. It's still not returning, or it's still not changing this max diagonal variable here. Must be something I'm missing here. So for result and results, if result at index 0 is greater than the maximum, so if like 10 is, or 9 is greater than 0, the max diagonal is going to change from 0 to whatever's in there. It stays as 0. We'll make this like 100. Ah, that's why they're different names. Okay, there we go. That's correct. We'll just call this, instead of max diagonal, call it max result. And then we can return max underscore result at index 1. Okay, let's try this. We'll probably run into some sort of error. For example 2. So we need some way to hold them both, both, both values. So max result will be equal to this. Okay, so these two test cases get accepted. What we can do is we can take this here, this max result at index 1. We can just say longest underscore diagonal is equal to max underscore result index 1. We can just check if it exists. So for result and results, if result at index 1 is equal to longest underscore diagonal, what we can do is we can say what will we do if result 1 is equal to longest diagonal. So if it already exists, what we can do is we can say like duplicates, or we'll say multiple is equal to true and break. So we know there's multiple longest diagonals. Then what we can do is just loop through it once more. So for result and results, if result at index 0 is equal to, how are we doing this again? So that's the longest diagonal. If results, or there should be 0 here. if result 0 is equal to longest diagonal, then we're going to say if max underscore area is greater than, or if result at index 1 is greater than max underscore area, then max underscore area is equal to result at index 1. And then we can just return max area. So if there's not multiple, then we can return longest, or not longest diagonal. We can return max underscore result at index 1. If not multiple. Okay, looks like I've spelled this wrong. Here what we can do is set multiple is equal to false to begin with. Okay, these two cases pass. Let's submit and hope that the rest follow suit. Wrong answer. Go right to the end as well. So let's check if there's multiple. So we should get a true getting printed somewhere. Okay, we don't need to print all of these. So there's not multiples. Not quite sure. What the answer is here. What we can do is when we get to here we can just print longest underscore diagonal and see what we'll get. We get 1500. So here we shouldn't be returning the longest diagonal. We should be returning the max. So wait, the longest diagonal is actually index. So we add the diagonal at index 0, so this should be this here. Okay, let's return this here. Should be index 1 still. Let's try this. Cannot access max area. Okay, so this should just be set to 0 to begin with. I did not mean to run that. Okay, these test cases pass. Let's try running the rest of them. Yep, and it's accepted. So thank you very much for watching the video. I hope it was useful to you in some way, shape or form. If it was, please leave a comment. I love discussing these problems and their solutions. So yeah, thank you once again for watching, and I hope you have a great day.